Hi, my name is Matt.
Hi, I'm Fabian.
Anthony.
Joe.
And this is Lab
8.
Interferometry.
Polarizing Interferometer.
Thanks.
Two important concepts in this lab are the concepts of interferometry and the concept of polarization. Again, in an interferometer, light from a single source is split into two beams that travel different optical paths. They are then combined again to produce an interference pattern on some sort of viewing screen. The two waves interfere as they superimpose on each other, and the interference pattern maps out the difference in phase between the two waves, with the maxima occurring when the phase difference is equal to a multiple of 2 pi. It is important to note that two waves must have the same polarization to give rise to interference fringes, since it is not possible for waves of different polarizations to cancel one another out or add together. Speaking of polarization, light consists of coupled oscillating electric field and magnetic field, which are always perpendicular by convention. The polarization of light refers to the direction of oscillation of the electric field. So in linear polarization, the field oscillates in a single direction, while in circular or elliptical polarizations, the fields rotate at a constant rate in a plane as the wave travels.
How could you visually inspect what was 0.38?
These concepts are worth learning about because they have heavy implications in metrology, specifically interferometry, which is used to measure lots of different surfaces, surface figures, and such. It also illustrates how quarter and half wave plates work in a very nice manner by showing how they can change the circular polarization of light in tandem with mirrors and thus isolate a certain section of light.
One significant result from this lab is that we can test an optical element that is inserted into one arm of the interferometer. When the two parallel beams interfere, we can see that we can see spherical aberration in this case in this test.
One thing I liked about this lab was the portion where we had to align the spatial filter. Although it was a challenging task and quite taxing, it was cool to be able to control the spatial filter to within microns of accuracy and get the spot to focus right down to within the pinhole of the spatial filter. One part that we disliked was how poorly the polarizing beam splitter performed with how old it is and how chipped it is. It was not ideal with the polarization states that it would reflect and transmit. It made it hard to analyze the performance of the optical elements that we added to the interferometer.